Today, we're talking about the differences between proportional and non-proportional situations. Let's start out just by talking about the features of proportional and non-proportional linear relationships. So when a relationship is proportional, we could write y equals kx. We've been doing that the last few days, right? We've written y equals kx a lot to write equations for proportional relationships. And we could also say that k equals y over x. Y over x is constant. It doesn't change. It's always the same when a relationship is proportional. That's really what makes it proportional. And k is also going to be the slope of our line for a proportional relationship. It's just really easy to find your slope when you're talking about a proportional relationship. When your relationship is not proportional, then y over x is not constant. This value changes, and we are going to use the tables below to take a look at what that means. So for example, let's calculate y over x here. So for this first row, y is 0 and x is 0. 0 over 0 equals 0. For the next row, y is 20 and x is 2. Well, 20 over 2 equals 10. For the next row, y is 40 and x is 4. 40 over 4 equals 10. And then for the next row, we have 60 and 6, and 60 over 6 equals 10. So you notice that I have 10 3 times, right? And then I have this 0 on top. So I don't want you to use 0 over 0 to calculate your rate of change for a proportional linear relationship. The 0 row doesn't count when we are talking about the ratio of y over x. In this case, we're going to say y over x equals 10. When x equals 0, however, y equals 0. That is the one row where y over x does not equal 10, and it is also the row that really tells us, hey, this is proportional. So you look for this row, and if you see it, you know it's proportional. The other way to tell that a relationship is proportional from a table is by dividing, by checking. Is y over x equal to the same value every single time that we're dividing two values other than 0? For non-proportional relationships, it's different. Check it out. So here we have 15 over 0. I'm not even going to write that because that would be undefined. In fact, I did write it. Let me erase it. We can't divide by 0. We get an undefined value. So I'm going to skip that row. Then here we have 35 over 2. Here we have 55 over 4. And here we have 75 over 6. I actually don't know what all of these equal just in my head, so let me type them into my calculator. 35 divided by 2 is 17.5. 55 divided by 4 is 13.75. And 75 divided by 6 is 12.5. Are these values equal? No, they are not equal. So we have 3 different values here that y over x equals, and they are not equal to each other. In this case, when x equals 0, y is equal to 15. And the important thing I want you to know here is that when x is equal to 0, if the relationship's not proportional, y will not equal 0, okay? That's what that symbol right there means. It means it doesn't equal 0. It could be a lot of different numbers if it's not proportional, but if it isn't proportional, then y is not going to be 0 when x is equal to 0. Our equation, we talked a little bit about that before. We said we have y equals kx for proportional relationships. So for this one, that's y equals 10x. And then for the non-proportional relationship, this equation is actually going to be y equals 10x plus 15. And you might be thinking, hey, where'd you get that 10x? We divided the values and they didn't give us 10. Let me show you how to get the 10. So as 7th graders, you talked about the slope of proportional relationships, and you talked a little bit about slope of non-proportional relationships too. When we have non-proportional relationships, we're going to use this formula to find our slope. It's a little bit more complicated than the formula that we use to find k, or our constant of proportionality. But we can handle it. Let's try it out. What we need to do is label a couple of points, choose easy numbers. I'm going to choose these ones, x1 and x2 and y1 and y2. There we go. It helps me to label them. So y2 is 35 and y1 is 15. and x2 is 2, and x1 is 0. There we go. So then we just need to subtract. Basically, I said this is 0.1, and this is 0.2. I subtracted the y coordinates, I subtracted the x coordinates, and then I divided. Let's do that. 35 minus 15, that's 20. 2 minus 0, that's 2. And that's going to equal 10. Oop, my 10 ran out of room. There we go, 10. Now, the neat thing about that is I picked the first two columns, but really I could have picked any values. Like, I could have done this one. So this could have been one of the x's I looked at. Let's try that out. Let's say that I wanted the first column to be my first point, but I chose the third column to be my second point. So let me label this 2, x2 and y2. So then I would have 55 minus 15 over 4 minus 0. Well, 55 minus 15 is 40, and 4 minus 0 is 40, and look at that, 40 divided by 4 is 10. You think it would still work if I had picked the very last column? Let's try it out. So now I'm choosing my last column, so now I have 75 minus 15, and I have 6 minus 0. So that's 60 over 6. Hey, there it is. It's a 10. So that's why my rate of change here is 10, because the rate of change of y with respect to x is always 10. What about the 15? Do you know where that came from? It's my y-intercept. So in my table with the proportional value, 0 was associated with 0. We see that right there, right? But over here, 0, an x value of 0, corresponds to a y value of 15. And that is where this 15 came from. We're going to learn more about that in future lessons. We don't have to learn it all today. Let's take a look at the graphs of these relationships. So this equation is graphed right there, and this equation is graphed right there. This one passes through the origin. Take a minute to highlight the origin because that's important to recognize. And this graph does not pass through the origin. There's nothing to highlight there. It doesn't go through the origin. Okay. In this case, Marie earns $10 per hour. And the other one, she also earns $10 per hour, but she gets a $15 bonus. So these are some distinctions between proportional and non-proportional relationships. With proportional relationships, y divided by x is constant. It's not constant for non-proportional. When we're looking at the table of a proportional relationship will have the row 0, 0. Or if it doesn't have the row 0, 0, you could correctly add that row to the table. By contrast, a non-proportional relationship, when x is 0, y is going to be something else. It's not going to be 0. The equation of a proportional relationship can be written y equals kx, whereas with a non-proportional relationship, you're always going to have a y-intercept. And then when we're looking at a graph, the graph of a proportional relationship goes through the origin. The graph of a non-proportional relationship will not go through the origin. And those are the key ways that you can tell apart proportional relationships and non-proportional relationships.